Hello guys, in today's video we are going to discuss the solution of the problem serialize and deserialize a binary tree. So let us look at the problem statement. The problem statement says that serialization is to store a tree in an array so that it can be later restored and deserialized in reading tree back from the array. Complete the function serialize, stores the tree into an array A and return the array. Deserialize deserializes the array to the tree and returns the root of the tree. So let us try to understand the problem statement with the help of an example. So let us say this is the tree which is given to us and we have to populate serialize and deserialize function. After operating on serialize and deserialize function, the driver code will do an in-order traversal of the deserialized binary tree and the resultant should be 213. As you can see, the in-order traversal of this tree is 213. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So let us say this is the tree which is given to us and we would like to serialize and deserialize this tree. By serialize, we simply means we want to convert this tree into array, and deserialize simply means we want to convert array to tree. Now in order to serialize this tree, which is simply we want to convert this tree into array, what we will do is we will perform an pre-order traversal of the tree. So we will perform pre-order traversal. There is a minor change in the pre-order traversal, which is usually in the pre-order traversal we don't traverse or we don't keep a track of the empty nodes or the null nodes, but over here we will keep a track of empty nodes as well. And we will see when we will deserialize this array how we will be using this empty nodes or none nodes in order to construct back our tree. But for now, let us just focus that in order to serialize the tree, we need to perform an in-order traversal and we need to keep track of none nodes as well. So let us see how we can do that. So let us do an in-order traversal of this binary tree and let us see if we keep a track of none nodes, then how does the in-order traversal looks like. So let us do an in-order traversal of this binary tree. So the in-order traversal of this binary tree will be 8, then 3, then 7, and then 8. So this 8 refers to this node, and since this is the last node, then its left and right child equals to none. So since its left and right child equals to none, rather than ignoring those none childs, we are going to store that information in our pre-order traversal. So let us store it and let us represent the none nodes by hash. So this is how the pre-order traversal looks like. Now let us continue our pre-order traversal. Again 8 will be observed and then the none nodes proceeding forward, then 10 will be observed and then 2 none nodes, then 9, 3, and since 3 is there, 3, then again 2 none nodes, and then again a 3 and 2 none nodes. So this is how the pre-order traversal will look like. Now given this pre-order traversal, let us see how we will be able to deserialize or how we will be able to construct a binary tree. So let me write down the pre-order traversal and then we will discuss it. So let us say this is the pre-order traversal of a binary tree which is given to us. So let us say this is a pre-order traversal of a binary tree. As we know that the first node in a pre-order traversal is the root node. So 8 is my root node. Now since this is a pre-order traversal and we have stored none nodes as well, then we know that in pre-order traversal the first thing or the first portion of the binary tree which is covered is the left side of the binary tree. So let us first populate the left side of the binary tree. So the next element is 3, and since we have to populate the left side of the binary tree, so this will be my next node. Applying the same logic, the next part of the binary tree, applying the same logic, the next element also will be inserted on the left side of the binary tree. So this will be my next element, and let us apply the same logic again, which is 8. So far we have iterated on these elements. Let me just cross it. Now we have observed a none node. Now since this is a pre-order traversal, so the first node which will be populated for 8 will be my left node, which is equals to none, and let us represent it like this. Now since this is a none, so over here we know that for this node it is not possible to have left or right child, because of which we have to move to the right portion of the binary tree, and over here also there will be a none. Again, for this node also it is not possible to have a left or right child since this is none. That is why we have to move up, and this is 7. So now we are at 7, and let us consume the next element from the array. So please remember, these two elements we have consumed it, and the next element is 8. So over here we will go ahead and once we have put 8 over here, then the next element is 2 hashes, which is the left and right child of the binary tree, and let us represent it like this. And again, since these are empty nodes, so it cannot have left or right child, because of which we have to move up. So now we are at 3, and let us populate the left and right child of 3. So left child we have already populated it, so the right child will be equals to 10. Applying the same logic, the next element is 9. So let us put 9 over here, and then the next element is 3. So let's put it over here, and then the next two elements are hashes. So let us put a none over here. And then again we have a 3, so the 3 will come over here, and again the next two elements are none, so the none will be here. And in this way, using pre-order traversal, we will be able to deserialize a binary tree from array. So that's the general idea, folks. Now let us discuss the pseudocode for this problem. So let us first discuss serialization portion. And in Serialize, a root is given to us, and we need to serialize this array into array format. So let us do that. So the first thing which we are going to check is whether this is an empty tree. If this is an empty tree, then we just have to return an empty list, which is this. If this is not an empty tree, then let us have a stack, and within a stack the first element which we want to keep is the root of the tree, and let us have the answer with us, which contains the pre-order traversal of the binary tree. Now we will iterate on this stack while stack is not empty. Then we will go ahead and pop the stack, and we will check whether the pop element is none or not. If let us say this is not none, then what we are going to do is we are going to append its data on our answer. So let us do that, and we are going to append its left and right child onto the stack. So let us do that, and please note we first have to append the right child rather than the left child. And the reason why we are appending right first rather than left is because of the nature of stack. We want left to be popped first, because of which we have to insert left at the last. So let us do that, and let us say if the root is none, in such case we need to append hash in our answer list. Please remember, we are appending hash also to represent none node in our answer list, and then towards the end we are going to return our answer. And in this way we will be able to serialize a binary tree. So that's the pseudocode for serialization, folks. Now let us discuss the pseudocode for deserialization. So for deserialize, our array is given to us, and let us see how we will be able to deserialize, or we will be able to construct binary tree from the array. So in order to deserialize, we will have a global variable I, and the initial value of I will be equals to 0. And then what we are going to do is we are going to check whether this is an none node. So if this is a none node, then we will go ahead and simply return none. Otherwise, let us construct a node. So the node will be equals to root, and let us call that node as root, and this can be constructed as node and array of I, and in this way we will be able to construct a node. Now comes the left and right part. Now as we know, if ith position contains root of a binary tree, then I plus 1th position contains left child of the binary tree. So we are going to increase our I by 1, and then we are going to say that the left child of the binary tree is the next element, which can be obtained via deserialization, which will be like this. And again, after consuming the next element, then comes the part of the right child, and the right child will be the next element afterwards. So the right child will be equals to root dot right and deserialize array. And after populating the left and right child of the root, we are going to return root. And in this way, we will be able to deserialize an array. So that's about the explanation, folks. Now let us see how we have implemented this in Python. So the code is pretty much the same as what we have discussed. Let us first discuss the serialization portion. So in serialize code, if this is an empty binary tree, then we are returning an empty list. Otherwise, onto stack, we are pushing root of the binary tree, and then there is an answer list which will contain the pre-order traversal. Then we are iterating on a stack while a stack is not empty. If this is an empty node or this is a none node, then we are inserting that none node, which is represented by hash, onto the answer list. Otherwise, we are appending root.data into the answer list and appending left and right child onto the stack. And please note, we are first appending right and then we are appending left. This is because of stack. And then towards the end, we are returning answer. And in this way, we will be able to serialize a binary tree. Now let us look at deserialize portion. So in deserialize, we are looking if this is an empty list. If this is an empty list, then it is an empty binary tree and we are returning none. Otherwise, this is the global variable which we have, and initial value is 0. And then we have the deserialize util with us. This deserialize util does the same thing as we have discussed in our pseudo code, which is if this is a none node, then we are returning none. Otherwise, we are constructing a root and then we are populating its left and right child. Afterwards, we are returning root. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.